All right, we are going to solve for triangles similar to what we did in 9.2a. Today it's going to talk about what we call the ambiguous case. Right? It's a scenario in which you are given a triangle in which you have angle, side, side, or side, side, angle. Okay. Reminder that when we talk about using law of sines, we said you need an opposite side with an angle. So you need a pair is what is the phrase that I used. Okay. All right. From here, we can solve for angle A using the law of sines. All right. The ambiguous case. There are three scenarios. Number one, the triangle doesn't exist. Okay. As in, this side that is opposite the angle 75 is too small, okay? Therefore not making a triangle. B, there is only one triangle, or C, there are two triangles. I am going to show a GIF on a little video here that will help explain it. Of ASS. So if you look in this case, we're given an angle, we're given a side, and then we're given a side, or SSA, however you want to look at it. Okay, so the angle is not the angle that's in between, all right? So we have learned, okay, we have been talking about the idea of the unit circle, and we have learned that sine of 30 is equal to 1/2. Well, basically, remember that when we talk about 1/2, what we're saying is it's a ratio, okay? So sine of 30 degrees in terms of this case means that the opposite side is half of the hypotenuse. So in this case, in order to have a triangle, the opposite side has to be 8. Well, since this side is not long enough, no triangle exists, okay? Now I'm going to adjust side A, and I'm going to make it a little bit bigger here. I'm going to try and get it to be 8. All right, so notice the side stops swinging. It shows that there is now one triangle, okay? And that is because the opposite side is half of the hypotenuse, 16. But I can also adjust the side opposite the 30 to be a little bit bigger. And in this case, notice how it is swinging left to right. So now you have a situation in which there are two triangles. And what we're going to do with our law of sines and law of cosines is we are going to show you how to find the measurements of both triangles. Okay. All right, so just that GIF there was supposed to help explain, the three different scenarios. I think the idea of the swinging side really helps. All right, so this is what you're going to do. The first thing that you're going to do is you're going to do your law of sines. So you're going to do sine of 75 degrees is to 5 as sine of angle A is to 10. All right, I am going to multiply out my 10, okay, and I'm going to get sine of A to equal 10 sine 75 over 5, and therefore A is equal to sine inverse of 10 sine 75 over 5. All right, I'm going to pull up my Desmos here. All right, so I've got to go, let's see, sine inverse, and I'll do a fraction here, 10 sine 75 over 5. All right, notice that it says undefined, okay? All right, and there's a reason for that, okay? I'll even, since we're on our calculator, I'll just do it separately. I'm going to do the top part of the triangle, 10 sine 75. Notice that that's a 9.659. I'm going to go back to my paper here. All right, so that means that I am doing the sine inverse of 9 point, what was it, like 6 over 5, okay? Well, you guys know that that's roughly the sine of 2, and we said that our domain for sine inverse has to stay between a -1 and a 1, and this is too big. It doesn't work, so therefore it is not possible. So one of the ways that you're going to tell that no triangle exists is basically your calculator is going to say error. So therefore, no triangle. Okay, so this is that first scenario, which, you know, the 5 is too small. Okay, basically what's happening here is this is what's happening. You have a triangle, like, well, you don't even have a triangle. You've got your side here that's making up the angle with the 75, and then you've got another side that's not long enough to reach the opposite side, so therefore no triangle exists. All right, here we go. Second scenario, all right? Notice I've got an angle and a side opposite, so I'm going to use law of sines. All right, I'm going to do sine of 23 over 7. I'm going to do angle A here, so sine of A over 9. Multiply out the 9. Okay, sine A equals 9. Sine 23 over 7. Angle A equals sine inverse of 9 sine 23 over 7. All right, I'm going to go back to my Desmos. Okay. All right, so sine inverse of 9 sine 23 over 7. All right, I got a 30.15. All right, we're going to round that to 30 degrees just to make life a little bit easier. Okay. All right, so therefore angle A is 30 degrees. Okay. All right, so now what we have to do is we have to determine whether or not there could be another triangle. Okay. All right, so this is how we are going to do that. We are going to take this 30 degrees and we're going to do 180 minus 30 degrees, and we're going to get 150 degrees. Okay. Next, what you have to do is you have to take your 150 degrees with your 23 degrees, the angle that they first gave you. You have to add them together and see if you get a sum that is less than 180 degrees. If you do, then that means a second triangle exists, okay? Because right now, if I look at triangle 1, okay? Triangle 1, I've got angle C, which they gave us, is equal to 23 degrees. We just calculated angle A to be a 30 degrees. If I add these two together, I get 53 degrees, which means that angle B is 180 minus 53, which is, what, 127 degrees. Okay, so that's triangle 1. But in triangle 2, we know that the original angle, angle C, is going to stay the same at 23 degrees. Angle A is going to be 180 minus 30, or 150 degrees. These two add up to be 173 degrees. So therefore, angle B is 180 minus 173, or 7 degrees. So there are two triangles that exist here. Okay? All right. So just so you guys have an idea of what's happening here. This other side is coming through here, making this also 7. Understand this is an an isosceles triangle, which means that if this is 7 and this is 7, that means this is 30 degrees and this is 30 degrees, which means the angle to the right of it, its supplementary angle, is 180 degrees, a straight line, minus 30, or 150, making this third angle 7 degrees. Okay? So that's why there is a second triangle. It's like that GIF that I showed you, that arm kind of swung. All right, so we have two triangles. I'll try and highlight them in two different colors so that you can see it. Okay, so in triangle 1, you have this angle up here, which is 127 degrees. So using a highlighter of blue, this is triangle 1, okay, with your 23, your 30, and then your 127. But now if I highlight in blue, triangle 2 is this one, okay, which has an angle of 23 degrees, 150 degrees, and then 7 degrees. All right, so that's why we have two triangles. All right, then we're not done, all right, because remember, and I'm going to just erase a little bit here, just make things a little bit cleaner, okay? All right, so we calculated this to be a 30 degrees, and then we figured out that this is 127 degrees, all right? So the other thing that we need to figure out is what side B is. All right, we're going to have to do that twice. We're going to have to do it once for triangle 1 and once for triangle 2. I am going to go back to using law of sines just because I think it's easier. So I'm going to do 23, 7, then I'm going to do 127, and then little b. So sine of 23 over 7 is equal to sine of 127 over little b. I'm going to cross multiply. Eventually, I am going to get the situation where b is equal to 7 times sine of 127 divided by sine of 23. All right? And then I just go and I just type that in. Let's see. Clear. All right. 7 sine 127 divided by sine 23. All right, it looks like I got a 14.307. On the quiz, I'm going to have you round to the nearest hundredth, so that 7 rounds the 3 to a 1, so 14.31. All right, so I say B is equal to a 14.31. All right, I have to do law of sines one more time, okay, but this time I'm going to pretty much do the same thing as I did over here. Just remember that in this situation, I said angle B was 127. Now I'm going to do it again, but this time I'm going to use an angle B of 7 degrees, all right, because now I'm doing the other triangle. All right, so sine of 23 over 7 is equal to sine of 7 over B. I might sometimes like even use like a prime. Just FYI, if I ever do that, prime just means the second triangle. Okay. All right. I'm going to cross multiply and solve, and eventually I'll get B prime to be 7 sine 7 over sine of 23. All right. Go back into Desmos. All I got to do is change this to a 7, and I get 2.18. Okay. So 2.18. All right, so we've seen a scenario in which there is no triangle. We've seen a scenario in which there is two triangles. So again, what you're going to do is you're going to do law of sines. You're going to solve for your angle. You're immediately going to do 180 minus that angle. Why, again, are we doing 180 minus that angle? Because if this is 30, 180 minus 30 is 150 degrees. That gives you the second angle A, right? So like A switched over here now, okay, is 150 degrees, 23 degrees. I have to see if I can get a third angle, and there's just enough, okay, to get 7 degrees, all right? So that's where that second one comes from, all right? All right, we're going to try it one more time and see what happens. All right, I've got a side and an angle opposite, so I got a pair, so I'm going to do law of sines. So sine of 65 degrees over a 13 is equal to, I'm solving for b here, sine of b over 10. I'm going to cross multiply or multiply out the 10. Sine of b is equal to 10 sine of 65 divided by 13. Remember to get the angle b. Okay, I am going to do sine inverse of 10 sine 165 over 13. All right, so sine inverse, sine inverse of 10 sine 65 over 13. Oh, I said 165, sorry, 65. Sine 65 over 13. Okay, and I got a 44.199, so I'm going to round that to 44 degrees. All right, so I've got angle B to be a 44 degrees. All right, so now what I'm going to do is I am going to take my 180 and I'm going to subtract off 44, and that's going to give me 134 degrees. Okay, so if I were to try and do this, okay, make another 65 degree angle and then sorry, I think I drew it wrong. Sorry. Okay, if let's see, we want angle B. Oh, okay. So if angle B is equal to 44 degrees, okay, and then if I were to try and draw it like this, sorry. So 44 is here, giving us this angle right here is 134. Well, notice that if I take 134 plus 65, that ends up to be what? 199 degrees. Well, that's impossible, okay? Because 134 and 65, you know, that's already above 180 degrees. So therefore, no second triangle exists, okay? It's not possible, all right? There is only going to be one triangle. And that one triangle is going to have angle B being a 44 degrees. So now I can just do 65 plus 44, which is 109. And then 180 minus 109 gives me 71 degrees for angle C. All right, so angle C is equal to 71 degrees. The only thing I have left to do is figure out what little c is. All right, so I'm going to do sine of 65 over 13 is equal to sine of 71 over little c. I am going to cross multiply and solve. Eventually, I get little c to be a 13 sine 71 over sine of 65. All right, I'll type that in. Okay, so 13 sine 65 over sine, 13 sine 71 over sine 65. All right, and it looks like I get a 13.56. All right, so therefore side C is equal to 13.56. Okay? 13.56. All right, so just remember that when we talk about solving the triangle, make sure that you're figuring out all three side lengths and then all three angles, okay? And then just to rehash one more time what you're going to do, okay? You're going to do set up law of sines and you're going to solve for your first angle. The first angle we solve for is B. We got 44 degrees. Immediately subtract it from 180 degrees. okay, to try and get your second B. Now remember, if this was B angle B prime, combined with our original angle A of 65, those two angles add up to be 199, which is impossible. So therefore, no second triangle exists, all right? When we did it up here, we got 30. We did 180 minus minus the 30, we got 150. So then we had our original angle of 23. We got our 150 degrees that we just solved for. And there was still enough, okay, less than 180. There was 7 degrees still available. So that's why a second triangle exists. Okay, so make sure you understand the difference between these two. Okay. All right, the rest of the time you're going to have to work on your homework, and then just be ready. We have our quiz. Reminder, things that you need to know. You need to know the area formula, so 1/2 times the two sides that surround the included angle. B, you need to know law of sines. C, you need to know law of cosines. I would make sure you understand this concept of the ambiguous case, because that will probably be on there. All right, I will see you on Monday for any questions.